Okay, hello and welcome to the Prom 9. Now this is a very important tutorial because it essentially means safety when using bench test equipment requiring probes. Like this applies to oscilloscopes, but it also applies to some other stuff, such as this. But this is going to be one of our subjects for examples. So, what is this video about? It's about mains isolation and earth isolation. I shall show you what I mean. Earth isolation is when this pin is not connected to any part of the circuit. Because in some circuits, the earth is actually connected to the circuit. And if you accidentally put your negative in a positive, you essentially cause a short through your earth wire to your scope or other test equipment, and if the current's high enough, bang! Both the scope probe can literally explode in a big shower of sparks and be potentially quite dangerous. So this is a very important safety technique. I'll also put a link to EV Blog's mains earth isolation video down below for extra information. And mains isolation is literally the live and neutral, or active and inactive, or whatever else it's called abroad, but live and neutral. Live is the big brown wire which has the fuse on, and neutral is the blue wire which doesn't have the fuse on. And the live is the dangerous one, although the neutral isn't exactly safe itself. Now before I start, I have to put out a warning because there are idiots in the world who will blame other people for their stupidity. I cannot be held responsible if you kill yourself while using this information, because I'm giving this information out as essentially free of charge, no warranty, all that legal malarkey crap that I don't fully understand, but that's that, isn't it? My brother's a lawyer, so I'm sorted there. So essentially, yeah. Basically, when working with this stuff, use common sense. Don't be a pillock about it. So the first thing we're going to do is mains earth isolation. Now first off, if you have a metal case, your device should be, not all devices are, connected, as you can hear from the bleep from our multimeter, in continuity mode. Sorry about crap lighting, but this is the best I can do. Main lights are on and I've got a little halogen down here. Which means, in the event the live or neutral breaks off and hits the case, rather than the case becoming dangerously live and electrocuting you, the circuit goes safely to literally the ground outside your house, building, office, whatever. Now what earth isolation is literally going to parts of the circuit. So this is an example of a non-isolated circuit to the mains. So we'll do that one because that one is actually connected to the earth. And what about this circuit board on the side? So as you can see, the earth pin. What of this is connected to the earth itself? Surprising! Less than I thought would be. Because it connects to the case down here, but parts of the case actually connect into the circuit. It's worth noting that out. Not everything, but parts of it do. Let's see if there's anything down here. Which essentially means, if you're measuring, such as, so you're testing this particular connector, do not connect this part of the probe to there, and then this to a positive part of the circuit, such as there. You will short circuit it and it will go bang. Connect only the negative, which in the scope itself is actually connected, because in the scopes themselves these are actually connected to the earth. So you can see how it causes a short circuit now, can't you? Well, I hope you can. Because this is also connected to the earth, which means you create a circuit. So connect this to the bit that's connected to the earth, and this to the bit that's not connected to the earth that you want to measure. Do not get it the other way round. It can be dangerous. Now, the other things on earth isolation is there's actually several types. Now, I did want to pull off some more examples than this, but digging out examples is not easy. But what about the electron? Is this earth isolated? I believe it is. And from the lack of a buzz, it is. Which means it doesn't matter which way round you connect your probe of your scope when measuring the noise, the electrical noise that could be produced by the signal. It doesn't matter which way round you connect them, because none of these are connected to the house building earth. Whereas some power supplies, such as laptop ones, I'm just looking through my stuff, seeing if I can just grab an example, which is a good example. I'm just looking. I was hoping my portable hard drive would be a good example, but it turns out that doesn't use the earth pin. The Xbox 360 PSU could be a good example. Bear with me. So this is my Xbox PSU or laptop adapter or whatever else. So we want to make sure that none of these are, that which one of these is connected to the earth, so we don't blow something up, so we don't blow our scopes and ourselves up. So we're secure there. I wouldn't suggest using your foot like I do, but I've fine practiced this over the years of my life, using my feet as hands. Very useful skill. So that one's not connected. Neither is that one. These are turning out to be really rubbish examples, but I hope you're still getting what I mean. This is why you should probably plan these sorts of videos. Neither is that one. Neither is that one. So this is a fully... None of the circuit is connected to the earth in the Xbox 360, pretty much. So that is a very rubbish example. However, I have thought of a very good example just now. USB. Let me just plug my Xbox back in. There we go, that's got that plugged in and repositioned that. So, put this on the bed, it's in the way. Now, in a desperate attempt to find some form of power supply that's mains earth, I've brought this computer home from uni. So here we have the USB, and here we have the motherboard. So say you're measuring your computer. Your USB negative is connected to mains earth. And this is the case for most USBs. Now this can apply to a variety of devices. which is why it's good to do these continuity tests on anything that connects to the mains that you are testing. Now, if this pin's plastic, which they sometimes are, such as on my portable hard drive, that's this pin, then you can pretty much know it's isolated. For something like the computer, say you're measuring the clock signal or something on it, you'd need a really big high megahertz scope for that, gigahertz one. You can then determine that not to connect the positive of your scope to it, only the negative to that part, because that's already connected to the earth, so you won't cause a short circuit, but you will if you connect that. Now, as far as I can tell, that covers the mains earth, but also go and have a look at Dave Jones' EV blog down on there, so you are fully covered. So, because I believe I've covered everything, but I may have missed a thing or two here and there. And once again, I encourage you big time to ask any questions if you're not sure on anything. Because, oh yes, I want you to not only be able to do this stuff, but do it safely, because we don't want dead engineers. Dead engineers are no good. We want live engineers that can carry on to do engineering. The next part, which will be on the next memory chip, will be of mains isolation, and you get devices which aren't mains isolation. The card ended a bit early, but now we're on to mains isolation. Now, under no circumstance, I must highlight this so severely, under no circumstance, absolutely, whatsoever, never, ever, ever, ever connect your scope to mains. Do not go dun dun on, because you will destroy your scope, you will destroy your probes, and you will probably destroy yourself. And it won't be the cartoony electric shocks, it will be painful. Thankfully, UK plugs have these lovely little divots that stop children's fingers and pillocks probing scope probes into the plug socket, and essentially have these lovely little safety things that push down a cover that only allows what should go into the plug socket to go into the plug socket. Sadly, the rest of the world doesn't have this safety feature, which is one of the reasons why British standard plugs and plug sockets are superior to everything else. Some people might be like, what? That's one of the reasons. Safety. If you want, I'll do a video on why British plug standards are the best. But never, ever, ever, ever connect these to mains. And the same goes with something like this. Although this does have a floating and ground switch, so if you do measure a mains potential with this that isn't isolated from mains, such equipment, make sure the switch is not set to ground position, because the ground floating literally disconnects the negative of this. If you knock it to floating, it disconnects this from mains earth. Knocking it to ground connects it to mains earth. Make sure that is not connected to mains earth, basically. So how do we tell if we're connected to mains earth? To mains potential, live and neutral? We do something called a continuity check, just like the other way. So for example, it'd be good if we could pull off some extra circuits here. Power supply circuit board would be good here. Do we have any? I'll grab something in a bit, but for now we'll just do the cables. So for example, we put a probe in there. That one will probably be the neutral. That's just a guess, so I might be wrong. And I am. Yeah, I'm right, it's neutral. And so we have connection. That's non-mains isolated, because it's just a cable. Now this can actually connect directly into circuits, especially in the PSU sections. And this is one of the reasons why PSUs are extremely dangerous when plugged in. Even when switched off, both these can still remain energizing parts of the circuit, especially if it's a software controlled power supply, such as in a PC or DVD player or other bit of commercial television equipment or something like that. Now we're going to show you exactly what isolates these from the mains, thanks to an electron power supply which the screws are being bastards on. So we'll move that one to one side and go with one I've dismantled before, because it's essential we get this through to people. This information could save your life. Abusing this information could kill you. I've dismantled these before. Why are the screws so damn tight? Right, we're not going to show you a standard transformer, but we're going to show you this how to check if it's isolated from mains anyway. So first off, we put one of the probes in the output. Put this on here. You can knock it to a higher resistance or the BP mode, and if you get no beep, it's not connected. Although be careful, this only supports a few ohms. It could still be connected in the kiloohm range. So sometimes it's not bad to knock it up to a higher range and also test it and watch the meter display. And I'm scratching my meter display here. So this, the actual part that plugs into the electron, is not actually connected physically to the mains, and that is through a device called a transformer. Let me just dig one out to show you. Now here's some small transformers, 2 of them. These essentially are just coils of wire round a core. Where's some paper or something to draw on here? Hang on. Let's use this. Excellent. So everyone see this? So you have your core here, and what a transformer essentially is you get a coil of wire that goes round the core there and out the other side, and it only goes round this core. It doesn't connect to anything else. Now this core can have several wire taps off it, from 2 to about a bazillion, and then one of these sides will be connected to the main, so live neutral, and the other side will also go round this core and come out the other side, and also can have many taps off it. This is not connected to the live and neutral in any physical way, so thus a DC circuit cannot flow. However, AC can, which is how the transformer works, but transformer workings is a whole tutorial in itself, and there are people who can explain it out there better than I can. But this is not physically connected to the live and neutral, so thus it's mains isolated and a heck of a lot safer. Although you can still have these build up, convert to either high current or high voltage, which can both be equally dangerous in their own right. But as long as it's within the voltage range of your scope, it won't blow it up if you connect it to the isolated parts of the live and neutral. Now I have not seen many devices that output the live into these. Normally when you see that, if you are testing something like your power supply or an output, and the output has a continuity with one of these, you've got a problem. And you do not want to use that power supply, unless if it's been repaired by someone who knows what they're doing. Otherwise, throw it in the bin. Trust me, it's better to waste the power supply than kill yourself. The same thing is as if the metal case of something like this is connected to one of these. You have a fault and the device is unsafe. Do not make the mistake and think it's safe. If anything, unless the circuit is meant to be connected, such as a household appliance, such as a shredder for example, that does not mains isolate. That has mains live and neutral going through it. Oh yes, it will still reduce the voltage, but in other ways through resistor banks and whatnot. So things like that, shredders, like your sort of kitchen appliances like mixers and stuff, they generally aren't mains isolated, the electronics in them. So steer clear of putting oscilloscopes anywhere near them, and do not use them opened up unless you know what you're doing. And hopefully some of this information will help you understand you do know what you're doing in future experiments. But remember, don't just rely on this one video. Search around, look for other safety information. And if anyone notices anything I missed, highlight it out. And also, once again, if you have any questions, feel free to ask. But as a general rule, if you've got continuity between your mains and your power output to your device, like in a electron transformer or transformer that you connect to your video recorder or something, generally that means electrical fault. Do not use. These are also kind of a safety device in their own right. And not only that, AC voltage off mains is the exact correct frequency that is in exact harmony with the frequency that essentially the electronics in a human work are at, which means they happily conduct and cause maximum damage. Keep that in mind. Now hopefully this video has been informative and has informed you of the hidden dangers, because too much health and safety these days is bullshit health and safety where it states the bloody obvious, not the stuff that is actually hidden killers.